ओके यहाँ पे इंटरनेट का थोड़ा सा इशू था तो I'm really sorry. Let me quickly complete the discussion before it just shuts down again. So okay, the thing is that rep 78 should be represented by 4 dummy variables. Why? Because it has got 5 categories. So Stata has a very easy way of incorporating dummy variables into the model. And there is a simple command. So let's do it together. Okay, let's do it together. Are you able to hear me? आप मेरी आवाज आ रही है आपको?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So type reg followed by the list of variables. Okay. Price and rep 78, but I would not press enter. Okay, I would not press enter because it will give me a wrong model. So just write down I dot before the name of rep 78. When you write down I dot before the name of an explanatory variable in a regression model in the Stata command, Stata understands that rep 78 is not a quantitative variable, it is a qualitative variable. Okay. The session is now restored. Okay, so let me go back. I don't know what's the problem today. There's a constant disruption. Okay. So I would write down this command, reg, okay, followed by price, which is dependent variable, and then followed by rep 78. But before rep 78, I would write down I dot. So मैं आपको ये कह रहा था कि when you write down I dot before the name of an explanatory variable, then Stata understands, okay, Stata understands that you are talking about a qualitative explanatory variable. So now when I press enter, you see what you get on the screen. Now rather than having a single coefficient corresponding to rep 78, you will have the coefficients corresponding to each category of rep 78. One of the category would not be appearing in the output. That category, which is not visible on the on the screen right now, which is in the given case, it is right. It is the category you see here. So the category 1 is not visible on the screen, while the category 2, 3, 4, 5 are visible. 2 in the given case means that you are talking about a dummy variable representing the code 2 of rep 78. 3 actually means that you are talking about the category 3 of rep 78. So the results that you can see over here, right? These results, they are actually representing the results for the mentioned category of rep 78 as compared to the base category, the category which is not visible on the screen. As I was telling you, that by default, Stata considers the first category of the qualitative variable as the base category. Okay, what I mean by base category, let me explain. By base category, I mean a category which is actually, in a sense, a left out category, the dropout category, because you see it's not visible on the screen. But when I call it the reference category or the base category, I'm actually trying to say that this would be the category with which the results of all other categories will be compared. Okay, so you are getting the results for all other categories of rep 78 except the category, the first category, which is representing the worst repair record. So all these results that you can see over here, they give you the the results for the current category 2, 3, 4, 5 as compared to the first category, which is the code 1. And accordingly, you will interpret these numbers. Uh, the key word that you should remember when you want to, in a sense, interpret the meaning of uh, the coefficient of a dummy variable, right? Uh, Remember that the coefficient of a dummy variable represents, so remember this keyword, difference, okay? Rather than rate of change. There's a whole explanation for that, but for the time being, I am just mentioning it. So when you want to interpret the meaning of the coefficient corresponding to a dummy variable, you will interpret it in the form of a difference rather than rate of change. So you will not say that this represents rate of change, it will represent, so the keyword is now difference rather than rate of change. Now what does it mean in the context of the current results? This number, okay, let me explain. This number that you can see on the screen here, which is the number corresponding to okay 1403.125 is the reserve, is the coefficient corresponding to 2. Corresponding to 2 means that this is the reserves corresponding to the code 2 of the variable rep78, right? Whatever is the name of code 2, this number 1403.125 represent the difference in price, right? This represents the difference in price of car corresponding to this category, the current category, and the base category. So how can you interpret this thing? You can say that the difference in the average price of a car of the current category and the base category is $1,403, right? So as compared to a car with worse repair record की बात मैं इसलिए कर रहा हूँ कि because it is the code 1 which is taken as the base. So as compared to the car with rep 78 having the category 1, which means a car with worst repair record, you have to pay, because this difference is plus something, right? Whichever number is plus something, it would represent the positive difference, and whichever number is minus something, it would represent the negative difference, right? So as compared to a car with worse repair record, you have to pay $1,403 more for a car with a code 2, okay? यानी अगर किसी कार कोड कैटेगरी 2 में आता है, so you have to pay $1,403 more as compared to a car with a worse repair record. So all these numbers that you can see over here, 1403, 1864, 1507, 1348, they represent how much more you have to pay for a price for a car corresponding to given category as compared to the base category, which in the given case is the code 1. So these numbers 1403, 1864, they represent actually the difference in the value of the dependent variable price for a car belonging to the current category and a car belonging to the base category, okay? So if this difference is positive, it means that a car corresponding to this category is this much more expensive as compared to a car belonging to the best category. If this number is negative, then you would have the other interpretation. So as I have told you that by default, Stata will actually keep the first category as the base, and it will give you results for other categories as compared to the base category. But for example, if you want to change the base, आप ये कहना चाहते हैं कि no, I want to keep the last category, जिसको हम कहते हैं worst repair record, right? Sorry, best repair record. So I want to keep the category 5 as the best category, and I want to get results for all others and compare it with this. So then in Stata, you have to do it like this. Okay, just repeat the same command. From the review window, if I click, it will come in the command window, reg price, and then after I and before this dot, you should type the letter B. B means the base, and then in the bracket, write down the number or the code of the category which you want to keep as a base. Okay, so I mean, if you want to keep the last category as the base, तो आप यहाँ पे 5 लिखें. But for example, for some reason, if you want to keep the code 3 as the base, तो यहाँ पे आप 3 लिखें. You know, now when I write down 5 here, I dot में मैंने दो चीज़ों को increase किया है ना. I के बाद मैंने B लिखा है for the base, यानी I am changing the base, and within bracket I just write down the code of the category which I want to keep as the base. Now you see, when I click this one, you see what I get. Now as compared to the previous result, okay, as compared to the previous result, okay, let's slide this one. Now compare these two. Here and here. So what difference you can observe in this particular output? Okay. You see, in the first model, I had just used the default option of Stata, and it has kept the first category as the base. So that's why the code 1 is not appearing here. But now when I use the command, this one, okay, when I use this IB and within bracket 5 before the dot, I am telling Stata that now keep the category 5 as the base. That's why, as you can see here, the category 5 is not appearing, right? 1, 2, 3, 4 are there, but the 5 is not there. In the first, the 1 was not there. Here, 5 is not there. So now these results would be interpreted for the current category as compared to the last category, 5. So therefore, if I want to, in a sense, interpret the meaning of any of these, then I would say that as compared to a car with a repair record represented by the last category, right, code 5, how much more or less you have to pay for a car of the current category. So you see, the first number over here is 1348, okay. The first number over here, this one, the first number is minus 1348.5, right? So if the sign is minus, it means that as compared to the base category, as compared to a car with the best repair record, right, you have to pay this much less. You have to pay $1348 less for a car with worst repair record as compared to, right, a car with best repair record. So therefore, This again represents the difference in the average price of a car corresponding to the given category and that corresponding to the base category, which in the given case is the code 5. And the rest is just the interpretation, right? When you just look at this portion of the output, this is just telling you which particular difference is significant and which one is insignificant. So if you look over here, this difference of $1348, this difference of $54, this difference of $516, and this difference of $158, as you can see from these p-values, all these differences are actually statistically insignificant. So although the difference is there, but the result of the t-test is telling you that this difference is not strong enough, large enough. So therefore, there is no significant difference in the price of a car belonging to the given category and that of the base category. Okay, all other interpretation of the model would remain the same. Like for example, from here, you will be just interpreting something about the overall model. As you can see in the given case, it is the overall model is actually insignificant. Okay, because the p-value here, is more than 0.05, which means that on the whole, the fitted model is insignificant, which means that actually statistically, this model that you have fitted may not be that much useful. But for the time being, my purpose was not to consider whether this is a useful model or not. My purpose was to tell you that as long as Rep 78 is not quantitative, you cannot just fit it by treating it as a quantitative variable. You should actually represent it by making use of the dummy variable. So this is how you can use the dummy variable, right? And just to finish the topic, I would say that if you want to fit a model in which some of the variables like MPG, headroom, trunk, weight, length, turn, displacement, gear ratio, right? They are quantitative. And then you have the variable foreign, and then you have the variable Rep 78. If you do it like this, okay? If you do it like this, then up to here, from here to here, okay, up to this point, this is absolutely okay, because MPG, the variables, this set of variables is actually quantitative. Okay, the variables from here to here, they are quantitative. So therefore, there is no problem with interpreting the meaning of these coefficients. They will be interpreted as rate of change. But the real problems is here. If you fit a model like this, in which apart from the other variables from MPG to gear ratio, you have also included these two variables, foreign and Rep 78. If you do it like this, then this would be a totally wrong model. Why? Because you are treating these two variables as quantitative. But you know that they are not quantitative. They are actually qualitative. So rather than fitting a model like this, which would be totally wrong, and you should just ignore it, right? If you fit a model like this, if you just do it, if you put this I dot before the name of foreign, although foreign by itself is a dummy variable, so whether you do it or not, but if you just put it like this, you see, in the list of explanatory variables, I have kept all other variables as it is, MPG, headroom, trunk, etc. Why? Because they are quantitative. But with qualitative explanatory variables, I have written the word I dot. Why I'm writing I dot? Because I want to tell Stata that these two variables in the end, they are not quantitative, they are qualitative. So that's why I want to tell the software that implement the dummy variable rule on these last two variables. When I do it like this and press enter, and I get an outcome like this, then this output that you can see on the screen right now is an absolutely correct model. Okay? This is a correct model. You can interpret the overall model from here. Okay? As you can see here, the overall model is significant, and it is telling you that okay, that you can consider this model because on the whole the model is significant. And then you can come down here and you can see what is my fitted model. So your fitted model is from here. Okay, from this portion, and then you can interpret it accordingly. Okay, and you can say that this portion of the output, this is actually a correct model in which the coefficient from this point to this point, these are the coefficients corresponding to quantitative explanatory variables. So the meaning of these numbers would be interpreted as rate of change, right? All the numbers corresponding to quantitative explanatory variables would be interpreted as rate of change. Like for example, the first number minus 43 would be interpreted as, for a 1 unit increase in MPG, for every additional 1 unit increase in MPG, the price of a car decreases by $43, right? So all these numbers will be interpreted as rate of change, but this number as well as these numbers would not be interpreted as rate of change. They will be interpreted as the difference in the price of a car, in the value of the dependent variable price, the difference in the value of the dependent variable price for the current category, for example, foreign, as compared to the base category, which in the given case is domestic. So this 3064.515, this represents the difference in the average price of a car corresponding to the foreign category and that of a domestic category. So which means that as compared to a domestic car, you have to pay $3,064 more for a foreign car. So foreign car is $3,064 more expensive as compared to a domestic car. And the result of the statistical test is actually telling you that not only you have to pay $3,000 more, but this difference between the foreign and domestic car is also statistically significant because the p-value is less than 0.05. And these four numbers that you can see corresponding to the code 2345 of the Rep78 variable, they are also giving you the difference in the average price of a car corresponding to the given category and that of the base category, which is the one. So as compared to a car with worse repair record, how much you have to pay more or less for a car corresponding to given category. So these just tells you that you have to pay this much more for a car corresponding to these categories as compared to the category one. But the numbers over here are actually telling you that these differences are actually not statistically significant. So they are statistically insignificant. So the model on the whole is significant, right? And then the details of the model are something like this. Okay. So this is all about.
Excuse me, sir.
Yeah, please.
Sir, ये type of car में हमारे पास domestic base category है.
Yeah, because as I have told you, by default, if you just use this particular ये जो मैंने यहाँ पे लिखा है ना, ये जो, if you just look at on the screen, when I use the I dot option before the name of a qualitative explanatory variable, by default stata will take the first category. The first category का मतलब ये है कि जिसका सबसे lowest code है. By default stata will take the first category as the base category. So in case of foreign, the code for domestic is 0 and the code for foreign is 1. So by default, it takes domestic as the base category and foreign as the current category. So it gives you the result for the foreign as compared to domestic. अगर आप इसको change करना चाहते हैं, ठीक है? If you want to change this and you say no, I want to keep domestic as the current category and foreign as the base, तो फिर आपको इस तरह करना पड़ेगा, right? Here, if I say B and I just write down 1 because I know that 1 is the code for foreign. Now you see, if I say I, तो I dot की जगह मैं लिखूं IB bracket 1 dot foreign. Now see what happens. Now rather than domestic foreign, जो कि यहाँ पे आपको नजर आ रहा था ना, now you can see the word domestic here. Okay. Now domestic is occurring over here, which means now the model is considering foreign car as a base category.
Is a
It is
base.
giving you the result for domestic as compared to a foreign car. तो ये आपकी मर्जी है कि आप किस कैटेगरी को बेस रखना चाहते हैं, लेकिन इंपॉर्टेंट ये है कि once you know which category is the base, then you would interpret the result in relation to that base. समझ गया?
Okay, sir. Thank you. Clear हो गया.
Okay. So base कोई मसला नहीं है. Stata में बहुत आसान है, as I have told you right now. Okay, using this option, I followed by the letter B, and then in the bracket just write down the code of that category जिसको आप base रखना चाहते हैं. Instead, I will just do the trick. This is the shortest way of fitting a dummy variable regression model in Stata. Okay, is this okay as far as the dummy variable discussion is concerned?
Yes, sir. Okay.
Okay. I'm not sure whether we can go for the multicolonearity discussion. लेकिन सिर्फ एक चीज मैं आपको यहाँ बता दूं. When I was telling you something about the dummy variable rule, okay, here, when I was telling you something about this, the dummy variable rule, और यहाँ पे मैंने आपको ये कहा था कि for a k category explanatory variable, you should use k minus 1 dummy variables. One of the reason why you cannot keep, क्योंकि आप ये कह सकते हैं ना कि why not I just keep all the dummy variables here? Why not I also have a result for the category 1 over here? Multicolonearity के context में मैं आपको बताऊंगा कि for example, if you include all the 5 dummy variables here, then you will face a problem that we call the dummy variable trap. Dummy variable trap, right? Dummy variable trap का मतलब ये होता है कि if you include as many dummy variables as the number of categories of that particular explanatory variable, then you will face the problem that we will call perfect multicolonearity, right? लेकिन चूंकि perfect multicolonearity को फिलहाल मैंने explain नहीं किया है, तो आप इसको just for granted ले लें. If you include as many dummy variables as the number of categories, यानी अगर k categories हैं और आप k dummy variables भी include कर लें, then you will face the problem of perfect multicolonearity. और वहाँ पे मैं आपको ये बताऊंगा कि when there is a case of perfect multicolonearity, then the model estimation is not possible. फिर आपके पास ये result नहीं आएगा जो आप स्क्रीन पे देख रहे हैं. जब मॉडल एस्टिमेट नहीं हो सकता तो यूजुअली वी से कि दैट इज द एंड ऑफ द स्टोरी, क्योंकि मॉडल एस्टिमेशन तो नेसेसरी स्टेप है ना, उसके बाद बाकी स्टोरी आपकी चलती है ना. तो इफ द मॉडल कैन नॉट बी एस्टिमेटेड, सो यू आर स्टक ओवर देयर, यू कैन नॉट गो एनीथिंग फर्दर. इस फिनोमेना को हम इकोनोमेट्रिक मॉडल में कहते हैं dummy variable trap, right? Dummy variable trap. Dummy variable trap refers to a situation where you include, like for example, if you have a categorical explanatory variable like rep78, which has got 5 categories, और आप dummy variables भी, right, 5 रखते हैं. This one. If you also keep 5 dummy variables in your model, so if the number of dummy variables and the number of categories are same, then you will face a phenomena that we call dummy variable trap. Dummy variable trap का मतलब ये होता है कि the model estimation would not be possible because of the phenomena of perfect multicollinearity, जिसको मैं आपको explain करूंगा कि why the model estimation is not possible. So to avoid the dummy variable trap, dummy variable rule actually tells you that you should actually take it as k minus 1. Rather than k, you should take it as k minus 1. So if you keep one less number of dummy variables in your model, then you avoid this problem that we call the dummy variable trap. And that is the reason why for representing rep78, I have not considered 5 dummy variables, I have considered 4 dummy variables. तो आप कोई से 4 dummy variables लेने, right? The decision is yours कि आप किसको बेस रखना चाहते हैं. जिसको आप बेस रखना चाहते हैं, उसको आप मॉडल में ना रिप्रेजेंट करें, and the other 4 would be there. But if I put all the 5 dummy variables over here, then this model estimation would not be possible. Okay, and then that would be the end of your model. So that's why the dummy variable rule helps to avoid the dummy variable trap. Okay, so this is the. I think we should end here. अगर आप agree करें, यहाँ पे stop कर लें या should we continue?
जी सर,
काफी है सर.
Okay.
बिल्कुल
Okay.
आज के लिए काफी है सर.
All right. So I would suggest.
सर ये जरा
जी मैं आपको
ये जरा
record-
फिर
जी,
काइंडली आज ही शेयर कर दें सर.
हाँ मैं ये शेयर करता हूँ, आप इसको देख लें. At the beginning of the next lecture, if any one of you think कि आपको कोई चीज़ clear नहीं थी, तो I would quickly within 5 minutes I would repeat this dummy variable regression modeling ताकि आपकी ज़रा वो हो जाए ना. ठीक है, इतना मुश्किल नहीं है, लेकिन इनिशियली बाज़ लोग जब फर्स्ट टाइम करते हैं तो उनके लिए ज़रा मसला होता है ना. So just tell me at the beginning of the next lecture whether representing a qualitative explanatory variable in your econometric model is okay using the idea of dummy variable, or is there any is there still anything which is not clear. So within first 5 or 6 minutes we would just discuss that one, but then we will move to multicollinearity. Okay, thank you very much.
Okay.
See you next time.
Thank you very much, sir.
Okay, thank you.